Good morning, everyone. Today we are going to be talking about the difference between the probability of independent events and the probability of dependent events. So if you want to join me, I am on page 776 of your math textbook, and we're going to talk about independent events first. Okay, so if you look at what the definition of an independent event is at the top of page 776, the probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So remember, we usually put probabilities as fractions. So today we're going to be doing a lot of multiplication by fractions, okay? So if this is something that you're good at, you're probably going to have a real easy time of understanding it. And even if you're not so good at multiplying by fractions, you'll still have a pretty good time with this one because they're not that complicated of fractions today, okay? So let's look at an example. Look at number 1 with me. One letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Well, we look over there and we see that the tiles have 4, and then we see that the spinner has 3 choices, right? So here's the method I want you guys to use it. Let's look at the probability A first, and we'll just pick the tiles. How many vowels are in the tiles? You have G, B, E, and A. So that means the probability of a vowel is 2 out of 4, right? E and A, 2 out of 4. Well, what about the probability of the second part? Which one's a vowel? The only one there, it's A, B, and C. So the only vowel is A, and there's 3 choices, so that's 1 out of 3. Well, we turn that into 2 out of 4 times 1 out of 3, right? 2 out of 4 times 1 out of 3. Multiply that across and we get 2 out of 12. Another way of saying that is 1 out of 6. And we should always reduce our fractions, okay? So that is what independent events are. They will not be affected by each other. Okay, you pick the tile and you put it back, well, it's still the same probability, right? You spin the spinner, you haven't changed anything about the spinner, right? So the probability stays the same. We'll look at scenarios where the probability actually changes later on in this video, okay? But let's look at another example. The spinner and number cubes shown are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or a 4? Okay, as always, we just need to count out, right? So let's make the number cube our probability A first, right? Let's see, it's rolling a 3 or a 4. That's 2 choices on a number cube, which has 6, right? So that's 2 out of 6. Another way of saying that is 1/3, right? Then we have a wheel with 5 choices on it. One of them's blue, then yellow, green, red, and purple. So what would be the probability of not spinning on blue? Not spinning on blue. It'd be 4 out of 5, because no matter what, as long as we don't land on on the color blue, that's what we're looking for, right? So there's only 4 choices of that. So we turn that into 1/3 times 4 out of 5. 1/3 times 4 out of 5. We multiply across and we get 4 out of 15. The odds of rolling a 3 or a 4 and then spinning on anything that's not blue is 4 out of 15. Okay? If that's making sense, go ahead and pause the video and see if you can do letter A. I'm going to do letter A right now, so pause the video, and hopefully you're coming back with your answer, okay? A game requires players to roll 2 number cubes to move through the game pieces. The faces of the cubes are labeled 1 through 6. What is the probability of rolling a 2 or 4 on the first number cube and then rolling a 5 on the second? So just like, even though it's the same number cube, we should still do the probabilities separate, okay? So I'm going to have a probability of A and a probability of B. By the way, for those of us who aren't really sure why I'm doing A and B, I always just say A. A is the first event, and B is the second event. Okay, kind of keeps them in order. So on the first roll, I'm trying to get a 2 or a 4, which is of course 2 out of 6 or 1 out of 3, right? And then what is the probability of the second event? Just rolling a 5 is 1 out of 6. Well, 1/3 times 1/6 is 1/18. Hopefully you got 1/18 also. Okay. Now comes a very interesting idea at the bottom of page 777, which is probability of dependent events. If two events are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A occurs. If I just left out with that, you might be a little confused, wouldn't you? But let's look at this tray of ping pong balls. Okay, you see this? I have a little packet of ping pong balls here, and I've got 11 of them in here, right? You see that one's missing. It must have rolled somewhere. So if I am going to randomly throw these and try and grab one, like let's say I throw these into a bag and I try and grab one out. And I mark all of them like 1 through 11, right? What's the probability that I would pick a 2? Well, if there's 11 choices, it's 1 out of 11, right? Well, let's say I pick a 2, and it's gone. And then I draw again. What's the probability that I pick a 4? Is it still 1 out of 11? No. How many choices are there? There are 10 choices now. So actually, picking up a 4, the number 4 out of this, is 1 out of 10. This is a dependent event. It means that I have affected the outcome. Because on the first thing, I did something to change the probability. Okay? And that's what we're going to look on page 778. So go ahead and flip over with me in your textbook. Let's look at number 3 together on page 778. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. 4 oranges, 7 bananas, and 5 apples. Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. Okay. So, first of all, we have to figure out what's our probability overall. We have to find probability of A. Okay? We have to find the probability of A. Let's add 4 plus 7 plus 5. 4 plus 7 is 11, plus 5 is 16. So that means the first event, how many apples are there? There's 5. So what's our probability? Well, it's out of 16, and it'd be 5 out of 16, right? So that's probability A. Now, I don't have to add things up again. All I have to do is take 1 off of this 16, because we took 1 piece of fruit out of the basket, right? And so, how many apples are left? Well, if there were 5 at first and I take 1, there's 4 remaining. Okay? And so now, I go and multiply 5 over 16 times 4 over 15. And I can do some fun little cross-multiplying, cross-dividing, and I'm left, 1 times 1 is 1, 4 times 3 is 12. There's a 1 out of 12 chance that I would pick 2 apples. Okay? That's an example of a dependent event. Okay? So, let's go ahead and take a moment to work on B or C. I'll do both of them, okay? Pause this video and then let's do B and C together, okay? Hopefully you're back after doing B and C. And so it's the same scenario as number 3, and we're going to do the new pieces of fruit, okay? So probability of A, it's still out of 16, okay? But we're doing bananas, so it's 7 out of 16. And then the next one, probability of B, is 6 out of 16. 6 out of 15. And so we multiply 7 over 16 times 6 over 15. See, that's how easy it is to mess up dependent events. If you accidentally, like I foolishly did, not change the denominator, you're going to get a completely different answer, a wrong answer. So I'm going to take 2 out of both of these. I get 8 and 3, and I get 21 over 120. 8 times 15 is 120. 7 times 3 is 21. I reduce, and I get 7 over 40. Okay, 7 over 40. And then for letter C, I have pick an orange and then an apple. So I go, probability of A is 4 out of 16. And then the next one, probability of B is 5 out of 15. Notice that I took 2 different types of fruit, right? So there's 4, but this number is unchanged. This numerator is unchanged. So I go, I'm actually going to reduce these so that it's a little easier to work with. And I've got 1/4 and 1/3. And 1/4 times 1/3 is 1/12. It's a 1/12 chance of getting the orange and then the apple. What I want you guys to do on the comments below, I'd like you to look at the bottom of page 778, and I'd like you to give me the probabilities of 1, 2, and 3 in that guided practice, okay? A little bit of talk about this last week of our math class, all right? I misspoke when I did your assignments for this week, and I thought there was a lesson 8 for some reason. There's not a lesson 8 in chapter 9. So this is actually the last lesson that we're talking about. You guys have been doing such a great job with probability. You guys are rock stars. We're actually going to finish up with a small, not so hard test on chapter 9. You guys really shouldn't stress about it. It's just going to be finding that probability. You guys are doing such a great job with it. So here's what I'm going to do instead of a lesson 8 video tomorrow. I'm going to put out a Zoom room if you would like to do a study hall with me and ask me any questions that you have about finding these probabilities of lessons 1 through 7. So I'll be putting that information out later this afternoon, okay? So don't forget, at the bottom of either your Google Classroom or on YouTube, go ahead and give me your answers for numbers 1, 2, and 3. All right? Have a great day, guys. Can't wait to see all your answers. Bye!